Thanks, everybody. Yeah, it's great to see such a good turnout. I gave my first Ethereum talk. Is this? I should use both?
Yeah.
Okay. My first Ethereum talk for this very meetup, so it's fun to see how it's grown. I hope I'm not going to get any feedback there. So I'm going to be talking today about MetaMask. That's the browser extension I make. So here, before I get too deep, I'm going to talk about, just introduce myself. I have an English degree. I didn't start with technology. I've just been using computers my whole life because I'm a Bay Area person. This is half a slide from IoT World. So I built an IoT device that's unrelated to this. I did a little software engineering at Apple, and then a friend of mine who I worked at Apple with, Aaron Davis, he went to an Ethereum meetup and he got me all excited about it and started making MetaMask and eventually got me to quit and join him over here. So now we're building it, and yeah, we're seeing really crazy adoption. It's really early times. I'm going to be emphasizing the many ways that it's early times throughout this talk, and the many ways we're going to be improving over time. But more than anything, MetaMask is kind of an introductory way to explore the Ethereum blockchain landscape and what it might mean to use an application that interacts with the blockchain and what that means for the users and how that affects the kind of user experience they have. So I've kind of had some time to refine how I think about MetaMask, and I think of it, actually there was a nice metaphor that Eric made before this. He said you're kind of going for like a grease monkey thing. It's like, yeah, it's kind of a grease monkey. We're kind of making this sandbox. It's just like a browser extension. We're just kind of extending the browser, and we're saying, what if the browser did some kind of peer-to-peer stuff? And specifically, there's kind of two ways that we're adding a peer-to-peer layer to the browser and then letting developers play with that. We're adding a decentralized identity layer. So we're injecting identity, specifically an Ethereum address, which is basically a public key. And then we're also adding a trustworthy data source. So I'm going to talk about the implications of those two things. So the first thing is identity is this kind of weirdly missing API from the browser is how I would argue. I'd say like browsers got fired up and nobody added, we had public key encryption, but nobody said like maybe that should be a fundamental thing that's like part of your experience and you can log in and log out and really have control over what session data websites store about you. So MetaMask, the first thing it does is it injects an API for allowing you to declare who you are. It's just a public key, so its default nature doesn't really say anything about you. It says how much Ether you have, which is just network currency. But then it can also say more things about you as you use the website more, and they can learn more about you. And so you kind of control the interaction again. So, so today it's kind of complicated, right? You maybe give your secrets to, you give a password to a website, they store all your data, they might store some cookies on your page and then track you around different sites. So it's got some drawbacks, especially when you could kind of just have a key pair yourself. Where we're headed, and this is not where MetaMask is today, but where we're headed towards is decentralized IDs, and this isn't just MetaMask doing this. We are working with a variety of different organizations. We're working with Microsoft and Blockstack and Sovereign, and these different organizations, and W3C with their verifiable claims standard, which is basically evolving and developing this notion of a decentralized ID, a DID standard. And it's a file format, and it's kind of an exchange protocol, and what it basically gives you is a way to contain a bunch of statements about yourself that can be cryptographically signed by different organizations, and then you can provide those. So if I got a driver's license, that could be a claim from the DMV that says I can drive. I can carry that around and I can prove that to you. I don't necessarily need to log in. I can even give you basically, the DID would give you instructions. It would say, you can call the DMV, you know the DMV's public key, that's their job, and then you can actually phone home. Here's a pre-signed thing. You can even call them if you want and verify it, and that can all be very automated. So why not have DIDs in the browser? And that would let you kind of respect this principle of least disclosure, that when you go to a website, you should have control over what's being disclosed. And we're getting used to that user experience a little bit more with things like Facebook or Twitter login. But still, on Facebook and Twitter login, while they're maybe sharing that information with the third party, they still own all that information themselves, right? It's not like, the owner of your driver's license, it's not like the DMV vouching for your driver's license and, the post office vouching for your address and your university vouching for your education, right? So you can kind of decentralize these claims and kind of keep the responsibilities where they lay and disclose to individual entities just what they need to interact with you. So if you sign up with a service, maybe maybe Uber just needs you to have a driver's license and passing some driver's tests, and they can certify people to give out that. So they can claim that somebody's good to give a driver's test, and then they can claim that you're good to drive, whatever. So that's a way that you can kind of assemble these claims into a decentralized identity space. Today, MetaMask basically just injects Ethereum accounts. I'm kind of doing this whole talk assuming you have a base understanding of Ethereum. I've given a variety of talks on basic Ethereum. In fact, if you go on YouTube, you can look up Dan's Intro to Ethereum or something, and I'm pretty happy with that one. But the basic version of an account today, it's a key pair. So you can see here that each account, it's got a nickname, account 1, account 2, account 3, but then it also has the Ethereum address associated with it. And what we'll do is, through our API, we'll make that address visible to websites. So a website can see, oh, you're that address. And they can store that. And they can track as much as they kind of want on their site. That's the current way that it works. And so they could say, oh, well, you did this much, but you never disclose more than that to them. And additionally, we put in an API into these websites that allows them to propose transactions to you. So the basic kind of transaction is that you spend money, right? They say, like, would you like to, there's a nice example of doing like a video service. So if you want to put a paywall in front of your videos, you could just say, basically entirely on the client side, do you want to pay for these videos? And then if you do, you can just verify that that person's paid, and if they have, then you can let them see the videos. It makes it a little bit light. And this is a little bit ugly right now. We're refining what this looks like, and we're kind of continuously evolving what it should look like to get a user's consent for things. So eventually, I think it should look more like a friendly kind of disclaimer. It should look very informed but simple and unintimidating. For the time being, most of our audience is developers, and so they want these kind of low-level controls. So forgive us, we have these scary words like gas limit, which generally don't touch, but I'll show you how that works in a little bit. In addition to being a decentralized ID provider, we're also a decentralized data source. And this part's a little bit weirder. I think that fundamentally allowing people to manage their keys is obviously beneficial. But then we also inject this Web3 API that lets your website read from the blockchain. I think that this feature is going to be more valuable when we have browsers that are statically hash linked. But today, you load a website and it can load some data from the blockchain and some data from a backend server. So it's kind of less meaningful. It's kind of a convenience layer. If you know that you have some smart contracts at a given address, we inject an API that lets you read from the blockchain that your visitor provided. And so there's a cool link in there, and I think it's going to be more valuable, like I said, when we have hash linked websites, which means that you can visit an interface for a site that is peer reviewed, for example. So, just to kind of riff for a second, if we had a peer-to-peer Facebook and everybody was publishing their stuff to a blockchain-like entity, you want to go to a website where the newsfeed is going to show stuff transparently, for example, or maybe you do, maybe you like their top posts thing, and that can be like a branded thing, right? That's kind of a user interface layer. But if you want to know that I'm seeing all of the posts from these people, then you can do that. Because today you don't really get that guarantee, right? You go to a website, you kind of just trust them to show you what they want. Is Twitter hiding some posts? I don't know, they control the data source. As we develop browsers that have peer-to-peer capabilities, you'll be able to more credibly verify that you're getting the data as it was published by the people you're subscribing to. And that's a cool anti-censorship property. Oh yeah, so I totally spoiled this. I had a slide for it. Yeah, so website today. Problems, yeah. So I'm going to show you some sample dApps, decentralized applications. These are just things that are using MetaMask, just to give you an example of the sorts of things people are doing. This is Authentic. So I work at Consensus. We kind of have a variety of internal projects. Authentic is one of our kind of supply chain as a service platforms. And so it lets people kind of describe their supply chain with the UI and then go through it. So here you can see that there's this is like a car dealership, and you can see that a specific user changed the status from returned to available, right? And since it's all on a blockchain, everything's cryptographically signed, so you know exactly which user, or at least which keys, made a given claim. And so as strong as you can keep control of your cryptographic keys, you have these kinds of guarantees about the order of events in the history, and it's very reviewable. ETHLance is a cool app that's out there. This is not from Consensus. I just think it's a cool example of a live app today. People post job listings on here, and they're peer-to-peer job listings. So finder's fees for developers are pretty hefty these days, and so having a peer-to-peer kind of job listing site is pretty valuable. So both ends of that get to share the profit. So that's like a cool example of peer-to-peer, cutting out middlemen, giving people a bigger slice of their pie. Here's Aragon. They had a crowd sale a few weeks ago. I don't know if you caught it. They are doing this kind of decentralized board governance. They have like a few corporate clients they're trying to cater to. So the notion is that you represent the shares of a corporation on a blockchain, and now this interface that they have lets people vote, and then they can vote on expenditures, or they can vote on admitting new members to the board and things like that. So it's a whole dashboard and platform for managing a kind of corporate organization. Gnosis is a prediction market. They had a crowd sale, and their user interface is coming soon. And so this is an example of the prediction market. This is a flat, kind of uninteresting looking one. But the notion is that it lets people bet on future events. Another thing that's kind of cool to do in a peer-to-peer way for a few reasons. Here's Consensus Energy has a peer-to-peer kind of energy market. So in this context, we have a peer-to-peer battery, which can kind of own its own Ethereum account. And so now every time it stores some charge, it can like issue a token that represents the ownership of that charge, and so it can sell its energy in advance, and then people can redeem that energy and buy it. And it was cool because then we've met organizations that are making Ethereum-enabled solar panels, and so these devices would be able to basically conduct commerce peer-to-peer directly, right? You could have a solar panel that just kind of auctions off its energy to batteries that are in different people's garages, and just kind of sell that energy peer-to-peer to other people in their neighborhood. And so now, yeah, your solar panel can just be kind of working for you, your battery can just be kind of working for you, and we don't have to go up to the grid to kind of conduct that exchange. Okay, so it was advertised that we would have live code examples, so I brought you some pretty cool ones. All right, so here we go. The first, I've got a very simple app. I'm using Webpack Bin, which just happens to be one of those live code editors that recognizes the Web3 API that we inject. So that's cool. That's a good tip. It's really great for hackathons when you combine it with Remix, which is a Solidity IDE. So here you can see I've done some basic things. Well, I always listen for the load event listener, and then I listen for the load event, and then I've got a basic render function. You'll see these in the different examples. I'm trying to be framework agnostic here, so I'm just using pure vanilla JS. Then I set up, and this is the basic thing that you do when you're checking for Web3 browser, is you're going to check if Web3 exists. And the way you do that in JavaScript is you say if type of Web3 is not undefined, which is ugly, but that's the kind of hacky phase that we're in right now. And then if it doesn't exist, then you maybe hide those Web3 interface elements, or maybe you suggest that somebody gets a Web3 browser. It's not just compatibility with MetaMask here. This is compatible with the Mist browser, and Parity has their own browser. So part of our intention by using the Web3 is we're trying to encourage a standards-like approach. And I'm not claiming Web3 is the standard we're going for. Web3 is a really ugly and awful API, and although I'm going to show you how to use it, we're deprecating it like soon. So use these as like an example of how you can do it now. I'm mostly going to show you though how to use abstractions around it, and that's basically how it's going to be going forward. Web3 is going to be standing in for a low-level browser API that accesses the blockchain and identity. So we check for Web3. If we do have it, we pull for account changes. Okay, this is the sad state also, is that we have to set an interval to check if the account changes. We're gonna have events, a more evented API in the future, and then we get the balance. Okay, when we get the balance, we're gonna check if their account changed. If they don't have account, we're gonna say there's no account selected. Otherwise, we're gonna show the account balance. So we're gonna call Web3 ETH get balance on that account, and then we're gonna get back a balance. And it's gonna be in a way which is this really, really tiny number, this balance object. It's 1 ether is 1 times 10 to the 18th way. So way are really, really tiny. So we've got some convenience methods from way. And then you can see I've got 100 ether in this account. I'm on a test network, okay? So don't try holding me up here. It's not 100 real ether. Oh, actually I should reload. I guess it's not polling on that. So let me just reload and verify that it shows my balance. Because as you can see here, I have 79. Oh, there we go. And now it reflects that. And it does pull for account changes, so I should be able to switch to this one. And there we go. Now it changes to 120. So you can see what I'm basically doing is I'm injecting this Web3 ETH accounts object, and that just lets me identify to the site who I am. And they can then ask the blockchain questions about me. So if I have things published about me, if I, like my identity, my name, things like that, they can look that up once I'm logged in. So that's the basic login example. Cool. Here's a peer-to-peer tip example. I need to publish this more widely because I think a lot of people just want this. So hypothetically, if you had a website and you just wanted to ask for tips, so here we go. Let's say this account is my account. I want to accept tips at owner account. Again, I got my little render function. So if they press the button, so the tip button is going to submit a tip. I get that. I get the value they input. I convert it to way. I get the current selected account, and then here's the method for proposing a transaction. Send a transaction to the owner account from the account for that value. And so let's try it. Let's crank it up. Let's crank it up to 10 because I really like this website. So I hit tip. Oh, actually, I think I have to reload because I rebuilt the extension since I had this page open. Okay, so I go to this website. There we go. So I'm going to give it 10. Hit tip. There we go. And here's the basic MetaMask confirmation screen right now. I'll zoom in a little bit for your benefit. So here you can see there's some ugly parameters you probably don't want to mess with. Although if you're a real savvy Ethereum user, you turn down your gas price because you don't want to pay the miners too much. You want a smaller transaction fee. And then you can hit accept. And here I see the tip has been submitted. Thanks. And that's just because in the callback, I got a transaction hash. Now, if you wanted to wait until that transaction had been mined to prevent proper double spending, right, because they could submit that one, you would put in a loop here where you poll for that transaction hash against the blockchain for mining. So that's a basic tip. One of the most useful things today, so a lot of people would be quick to point out that the Ethereum network is not very robust in throughput of transactions today. There's a variety of projects that are going to increase that, from proof of stake to sharding, and those are things that I'm a big believer in, and we absolutely need to do those because it's just not that useful in its current state. But what is really cool and useful even without that state is that since we have key management right in the browser, we actually don't need the blockchain to sign cryptographic claims. So for example, I've got a personal sign example. I'll show here's the code is gonna look something like this. When I click the button, it's gonna make some text that says hello. It's gonna convert it to a buffer, and then it's going to send it to me. It's going to send it in the method personal sign, okay? And here I'm using a really low level method, so you don't have to think about that too hard. But when I click personal recover, okay, it's gonna ask me again, and here's that hello message. So what I've done is I've given you a kind of UI for presenting cryptographic challenges to the user that they can then sign or not. So that could be your terms of service. This could be a JSON web token for establishing a session so that you know that you have an encrypted channel of communication with your user. And yes, or you can then just save that in your database. And now you can send encrypted messages to your user, all sorts of cool stuff. I'll then sign it. And oh yeah, this example is not very UI rich, but in the console, it says it got recovered. One sec. There we go. Yeah, so it successfully recovered the account that I signed with. So here's the signature, it recovered, and then, so it both took the signature and then I had some code that recovered it. And I have that, that's on ETH sign tests. So if you want to go on GitHub, you can find that here. My GitHub name is FlySwatter, so ETH personal sign examples. And there's some good blog posts about that method. So there's people who have already made drop-in like server-side libraries for establishing session tokens using the signature method. So that's just like a fun bonus thing you can do if your users have a Web3 browser. The last big example that I want to share with you is using a smart contract, because that's kind of the cool part of Ethereum, right? I'm going to give you the most dead simple smart contract, okay? But I'm going to show you how you would program that in Solidity, and then how you would take that into JavaScript to allow a website and a web user of MetaMask to interact with that. Okay, so here I've got a very simple counter contract. So it's got a value of 1, it's got an increment function, and then has a get function for just getting that value. So what I can do is I can just click create. If you've used Remix before, it's pretty cool. It's basically got a whole compiler and web IDE for making smart contracts right in the browser. And I can just say create. Oh, I have to reload. Same problem as before. I've been working on the extension. Okay, so it takes a second for the compiler to load. That is a real thing. I think we're going to probably eventually inject a compiler into the backend. I don't know. That's up for discussion. So here we go. We hit create. And here in this case, you can see the transaction, it's not going to another address. It's going to a new contract. So what I'm doing is I'm publishing some code onto the blockchain that's going to then become part of the protocol. So I can accept that. And then over here, you can see that, and I'm running on a test blockchain, so everything's mining instantly, so forgive the zero latency, that is not what it's like. But here you go, you can see I had a transaction cost, and then I've got an address for it, and then I've got some contract details and things. So what I'm gonna do is I'm gonna copy that address, and I have another little, I'm gonna reload this, I have a UI for that counter interface, and I'm gonna show you how you would interface with that. You need two things to interface with a smart contract using JavaScript. You need its address, and then you need its ABI, which is its application binary interface. So its address is, we're just gonna paste it right there. That's the new address. And the ABI, I believe, is actually the same here, but I'll show you where you would get it. In Remix, you would go contract details, and then it's this interface thing. So you just copy that, go over here, and it's just gonna paste it right over there. And what that does, that's just enough metadata to describe all the functions in it. So you can see that it has one that has a name, value, outputs, type, uint56. Oh yeah, that describes our value function, right? There's a getter. Since this is a public method, it creates a getter for that. And then it's not payable and yada, yada, yada. And what that lets me do is I'm now gonna use not Web3, I'm gonna use this other abstraction library that I recommend. If you're trying to make a dApp ASAP, try out ETH.js. ETH.js is this really great abstraction. It's very similar to Web3, but it returns promises, and it has really clean stack traces, and it's very modular and 100% test coverage. And when I'm debugging people's issues with this, it's so much faster. So if you want my help, you're doing me a favor by using this. Okay, so I get that contract address in the ABI, and then in the setup function, what I'm going to do, it's going to look something like this. You're going to make a new ETH, and you can see that I passed the ETH object, the Web3 current provider. That's its constructor. I don't know. Can you see that well? So the current provider is the low-level API. That is like, it's basically enough to send methods to the backend and get the responses out. And when we say we're going to deprecate Web3, we're really talking about deprecating it in favor of just a current provider-like thing that's going to also have subscriptions. And so it's just going to be really lean. It's not going to be this big bloated Web3 library. It's just going to be enough to basically wrap an abstraction around and then use a library that resembles what you like to use. So then we take the ETH.js contract. We say new ETH contract. Now I'm going to make a class of the ABI that I just made. So now I've got this counter class. So it represents like any contract that follows that ABI. And then I'm going to make an instance by calling counter at that address. And then I'm going to say load counter value. And that's going to set an interval. And on that interval, every 500 milliseconds, it's going to call counter get. And you might remember counter get was one of the methods that I made. So you can see that it just added those Solidity functions directly onto the JavaScript object. And so as a result, I'm able to just do a promise. If you have async await in here, you can just await the result. It's like a really wonderful experience. And then you get the result. And one of the nice things ETH.js does is it always returns an array from a contract because you can have multiple return values. So it's just like, rather than do this weird thing where sometimes it's one thing and sometimes it's an array, just always an array. So in this case, it's a value, so it's result 0 to string. So let's see. No account selected. Oh, let me see about that. Wait a minute, I have an account selected. Wait, let's see, can I increment? Oh, wait, attempting setup, rendering no account selected. Huh. Okay, hold on, let me reload this. I wrote this up a little earlier. There's obviously like some kind of bug. It has to check for the current accounts. So let's see, is that the right address? No, we need, I'm gonna grab the latest address, copy that, put it in here. Okay, so you can see there that it was 3. Let me, oh, so that was 3 on another instance of it. Okay, so anyways, let's, yeah, I almost want to just use that, but I'd really like to show you instead. So let me see, BBE is the contract. Reloading one more time. Otherwise, I'm just going to use this other one. I deployed the identical contract a little bit ago. Okay, let me see, have we got BBE? No. How do I make it save the thing? Okay, so anyways, oh, and this time it didn't recognize it. Okay, so this one's a little buggy. This example, I'm going to give it one more reload, and then I'm going to move on. But yeah, I'll show you how I'm going to interact with the two. So over here, one of the nice things Remix does is it gives you these buttons, so I can actually get the value. When I press that, you can see it flickers. That's because it's getting the current value. Yeah, value is returning the same thing right now. And actually, they have an increment button here. Oh yeah, so they're automatically generating an interface. So this is the increment function. It's going to write to the blockchain. So I'm just going to write to it from here too. And you can see that now when I get it, it's 2. What I was trying to demonstrate is also over here, it would do the same thing, but apparently I wrote a little bug in here a little while ago. So sorry about that. That should basically do the exact same thing, but it's not even recognizing the account. So there's some bug over at the account recognition section. Okay, anyways, yeah, so that's ETH.js contract. It's a really nice library. It makes this stuff a lot easier. If you're writing a smart contract, it's basically using a JavaScript version of your current contracts. Yeah, and there's ENS. Yeah, so that's basically it. So I think I can go into questions and stuff. So yeah, thanks. Yeah.
It's a dumb question. Where did the gas come in when you increment? Are you paying gas? Is anybody paying gas when that occurs?
Yeah. So every time, it's basically when you write to the blockchain. When you want to write to the blockchain, gas is what pays the miners or validators of that chain to basically add that to the state. So Ether as a cryptocurrency exists to meter and limit the usage of this big shared computer. So if you saw over there when I was in Remix and I said increment, it proposed a transaction, and you can see that it actually proposed a transaction fee. So at the current gas price of 20 GWei, which is a not user-friendly word for gas, or I can drop it, and you can see the transaction fee goes down to 0.53 ETH, and yeah, and I'm sorry, but yeah, our price feed API broke like 2 days ago, so it doesn't show the dollar value, but 2 GWei today I think is like a penny. Okay, that 20 would be, yeah, maybe like 10 cents or something. So you kind of bid. So what the gas ends up being is it's kind of bidding for miners or validators to include your transaction in a block that they mine. So.
And if you didn't give a substantial fee, you might wait quite a while.
Yeah.
For that increment to occur.
Yeah. In fact, at the moment, and we're gonna open-end it more in the future, but right now we don't even let you do 1 GWei. It's because we had way too many user support requests. People just saying, I tried to submit a transaction, it's never getting mined. There's actually a really nice website called ethgasstation.info. And all they do is record metrics and stats on gas usage. So you can see, given a different gas price, what the time to confirm is. So if you, time to confirm, right, if you give less than 10 GWei right now, you can be waiting 35 minutes, right? So So yeah, if you don't mind waiting a while, bid low, because the blockchain's kind of forever, right? But if you need something processed faster, then you need to pay the gas just to incentivize miners to do that. Yeah.
Can you talk about your architecture for build MetaMask on backend?
Yeah, sure. Yeah, let me just type GitHub because that auto-completes the MetaMask these days for me. Yeah, so we have a little architectural diagram that I can point to for this. I'm gonna have to zoom way out for it to be useful. Okay, so when you go to a website, we're an extension, and an extension gets a few things, okay? It gets a content script, it can have a background script, and then it can have an arbitrary number of UI, user interface scripts. So in the background, this is a separate process. We store private keys in local storage. Then via content script, we establish a communication channel between that background process and the web UI, and through that we inject a script tag that knows how to then talk to the content script, and we just basically ferry requests from the web interface up to the back end. We've basically posed a totally new use case, I guess, to the Chrome team. There's a bug where sometimes we inject like a millisecond late, and so it doesn't feel like a web UI. But the Chromium team has made it a priority, and they're saying that they're working on that actively, so that's cool. Go look up that issue and star it if you want to see that get fixed sooner. Because I think it's a cool feature for any extension that wants to play with extending browser APIs. So. Yeah, and then this little pop-up here, it's what we call the MetaMask UI, and it just has its own communication channel to the background process, so we're able to just render the same stuff. It has a Web3 instance in it too, so we're able to just draw stuff directly from the blockchain in it. Yeah. Yep.
This may be too narrow, but when you it seems like when you click a contract or something, it automatically pops up the UI and kind of pre-fills out the contract, the metrics for you. So I look at that, I click on something on the web app, and it somehow pops up the MetaMask UI. So where does the path?
Right.
Oh, it goes all the way through the background.
Yeah. So yeah, it goes. Yeah, when it pops up, so you click a thing, and there's an object in here that gets that click, and then it fires a message across the post message stream over here, and then it posts a message over to the background process, which then uses an extension API to open a pop-up over here. And open our UI pop-up. And only extensions can actually give you pop-ups that don't have a URL bar. So there's a little bit of a safety measure that's nice there, where if you don't see a URL bar, well, you know that it was your local browser doing it. It wasn't just some scammy thing. Yeah.
This is sort of a general question. Do you see parity or misbrowser as a competitor?
Yeah, do I see parity or misbrowser as a competitor is the question. So they're obviously doing a similar thing. They're trying to fill a similar role. I don't think competitor is quite the right role in a totally decentralized ecosystem. For example, when we have a bug, it's really nice to be able to say, for users to be able to go to parity, for example. I think they kind of satisfy different use cases, is why I keep working on it. If I thought there was no unique benefit to MetaMask, I wouldn't. But I think that what it lets us do is it lets us ask questions about what should these APIs look like in a browser. And specifically, MetaMask makes it a little bit more adoptable. It's just easy for somebody to hop in, and they just install an extension. It's a little bit more buy-in to get somebody to download a whole thing, although it's getting a lot better. I mean, honestly, parity's really fast now. They're working through a lot of stuff. I mean, I run, you can see actually that I'm running parity right now, and I often will point my MetaMask at my parity, specifically for slow to load dApps, like dApps that need to read from the blockchain many times. It's just faster to read off of a local node. What MetaMask does otherwise, it's like a light client. It's calling to our trusted server, which is not very decentralized. And we're actually actively working on, we're using some IPFS-based transports to basically gossip Ethereum data in the browser, but that's all work in progress. So a lot of what we are is, minimum viable, like what's it take for normal people to try it out and play with it, and experiment with what those APIs can mean for them. Yep.
What are 2 to 3 dApps you'd like to see built on top of MetaMask?
Oh, 2 to 3 dApps I'd like to see built on top of MetaMask. Yeah, that's a great question, because I made MetaMask because I wanted to make dApps, and then I was like, the user login story isn't really solved yet. So one of my things that I really want to see is I want to see a great peer-reviewed debate system where people make claims. You have like scientists like who are like academically verified claims, attesting and backing up and citations and pros and cons and I don't know. It's probably a pipe dream that people would like listen to reason or anything these days, but having cryptographic certainty behind it, like it seems like, and Gnosis kind of does this, right? Once you have prediction markets that are saying like, oh, well, the odds are overwhelmingly that the global temperature is gonna rise, dramatically, and then anyone who says otherwise can literally put their money where their mouth is, right? And there's like a very cool kind of future forecasting feature of prediction markets, so maybe they'll end up filling that role instead. But yeah, one of my original draws was debate. Maybe I took too many debate classes. Yeah. Or 2 or 3. I'll give you one more. Governance. Yeah. So Boardroom is kind of doing that. Consensus, we have a group. It's going to be like a really modular governance system. So it's going to be like, okay, it's kind of like creating a new identity, right? But to make a transaction, to sign it, it's not just you signing it. It might require 2 people signing it, or you might have a drag and drop consensus algorithm. You might say it's a 2/3 thing, or you might say it's by share, right? You could do the corporate thing, or you could do any variety of things. And the cool thing about Boardroom is they're making it modular, so you'll be able to you'll have like a sort of app store for governance components, right? And then experiment with organizations built out of these. Yeah.
Does the user have to install the plugin? Can you run in the background?
Yeah, great question. So the question is, does the user have to install the plugin to run in the background? Not for long. we have a project where thanks to some new browser APIs, there are some ways that we can create a blockchain client in the background that is shared between multiple sites. The secret sauce is the shared worker API. So yeah, we've got some successful experiments working on that. The problem is it requires buy-in from website developers. They would have to include a script tag, but you could create a kind of script tag only blockchain client for websites. That said, just kind of building on the browser. Is the browser really the ideal platform for this? Because like we said before, you visit a website, you don't really know where it's loading its data from, even if you have MetaMask installed. And even if it is loading its data from the blockchain, you don't know just by looking at it. So I really do think that peer-reviewed interfaces are going to be kind of the future of trustworthy interfaces. And eventually that will probably look like something like maybe a custom browser. And really to establish trust in that browser, you'll probably need it down at the system level. And to establish that, you need buy-in from the chip makers. I get to hang out with Intel this week, so I don't think that's a total moonshot. I think that there are people that are invested in establishing decentralized trust at the lowest layers of hardware, and so it's fun to see what we can build these things out of.
Have you heard of Unity 3D?
Have I heard of Unity 3D? Yes.
Any chance for integration or something?
I've wondered what that would look like. So it would be let's say you're in a VR world, and then you eat the burrito, and then it proposes a blockchain transaction, and then you have a way to approve it, something like that. Because part of why it works in the browser is we're this extension, right? We're outside of the application, so the application has an API for calling out. So maybe if we had a system level user identity extension, it's a conversation, we come back to it every once in a while, obviously, because VR is cool. Every once in a while someone's like, what'll it look like for VR? And we're like, I don't know, write that blog post, draw a sketch. I think we'd all like that. I'm not sure any of us know exactly what that looks like right now. Not spending enough time in VR. Yeah.
Hey, thanks for the great presentation.
Thank you.
Okay, so I wanted to know if MetaMask deals with enterprise-based identity. So currently it looks like you guys deal more so with consumer device-based identity, right?
Yeah.
Is there any plans in your product roadmap to go into enterprise or organization level?
Yeah, so we work a lot with one of our sister projects, Uport, which talks a lot more to the enterprise side, and they are interested in the decentralized ID kind of standard evolution, and they have very different requirements for security than the average user, right? No enterprise is going to install a browser plugin, so partly making a plugin-less version of it that could be hosted on an internal firewall or something would be a prerequisite to having a white label version of MetaMask. So.
Is that why Uport is partnering with Microsoft?
No. Microsoft has a division that's interested in developing these decentralized identity projects. So yeah, we work with them because they've got some common incentives. So yeah, that's just a natural collaboration.
Very cool. Thanks.
Yeah.
So does the user have to click the confirmation button to make the payment?
Yeah, does the user have to click the confirmation button? Yes. That's like one of the first most basic things MetaMask did, is because before MetaMask came along, what a lot of people were doing was running a local blockchain server and visiting sites that had permission to talk to their local server, and they would just auto sign everything. And yes, people lost funds like that. Like they would have a firewall down, and then people literally went to the Ethereum Developers Conference with a firewall down with an unlocked node running, and then just get their accounts drained. So yeah, having user confirmation before anything's spent is like one of our fundamental kind of security promises. Yeah.
Can you put that into the iframe?
Could you put it in an iframe? Yeah, I think we could. I think part of that, and I think that's maybe how Parity does their signer. And there's different problems that come up with that. If you're going to inject an iframe into somebody else's page, like, are you going to interfere with the styles, or are people going to trust that? Does it introduce phishing risks? Parity has a background security image, so they try to establish trust that way. I don't know if the average user is savvy enough to recognize that. But yeah, we're exploring different ways. We actually just got a new designer on our team, and we're kind of, giving him a chance to step back and look at ways we can, streamline these in ways that feel more natural to people. Yeah, maybe it'll be iframe, but yeah, we're weighing the benefits and the cons. Yeah.
I want to show you server expenses when you first started this and how they used to work that.
Oh yeah. Oh, how much are I should know that. Our server infrastructure team basically spun out. It's its own team called Infura within Consensus now. I don't know their daily stats. Like every time I hear them, they're bewilderingly high numbers. What are their expenses exactly? I literally am not qualified enough to know. You can ping people from Infura, like Michael Wooler, or on Twitter, or I can get you in touch with them later. Yeah, we've got a team. They work hard on it. It's kind of it's kind of bootstrapping it, and yeah, that's a server expense. And that's one of the things that pushes us towards doing this. We're doing work with IPLD, which is it's kind of like IPFS's gossip protocol. And what's cool is they wrote theirs in a really transport agnostic way, so that it's not just TCP UDP. It can also be put into WebRTC, so we can gossip blocks that way. So yeah, it's not going to be too long before we're doing that, and that's going to dramatically lessen our load. But there will probably still be like some kind of centralized trust in MetaMask until we're running like a full WebAssembly client or something. Because whose blocks do you trust, right? You're basically going to need them signed by somebody, because in WebRTC you can just emit whatever data you want under whatever subscription. So we have to lock down what the client will trust in some way. Yeah. Cool. Oh yeah, in the back.
So what are the other big pain points in developing dApps today? You're solving the identity piece, but what are kind of the other
Oh yeah.
obstacles to get them doing?
Yeah, right now the Web3 API is, so the question is, what are the other pain points developing apps? The Web3 API is really painful and not great at making queries. Like most people will store their blockchain data in the form of logs, which aren't even, like if you really get into it, they're not incentivized by the consensus protocol, so there's no incentive for peers to share them with each other. So in the long term, they're just the wrong way to store data. But that's the best query method people have today. So we need way better query mechanisms. I think eventually, maybe this is the WebAssembly future or something, but you're going to have a client, you're going to have a contracts context, and you'll be able to just kind of like observe its variables freely, and run your own filtering logic, or there'll be like a GraphQL like language or something. IPLD has a language they're working on called IPLD Selector, which it looks like CSS, but it's for traversing Merkle trees. That looks really hopeful. But yeah, just data querying from the blockchain is like so immature right now. It's like brutally awful. The projects that have performant layers on top of the blockchain, they just index and provide their own APIs. At Consensus, we have a cool project. Wait, I always mix up its name with Alethea, or it's like a graph database layer on top of the database, so the blockchain, so you can make advanced queries and stuff. But that's like a huge caching layer. So Yeah, and that's, as an aside, I think that's a nice opportunity to talk about maybe like scaling and like where this is eventually going to go, because the other big user interference problem is just latency, time to mine, transaction costs, yeah, all that speed stuff, and the fact that to have a full blockchain client, you have to have a lot of data that is maybe not relevant to you if you're not a miner. I think that in the future we're going to have very, very lean kind of light clients that maybe only store the contract state that you're interacting with. So while today, if I load ETHLance, I should just kind of have the ETHLance data that I want to load present. And what's cool is if my blockchain client has that, when I update new blocks, I only get the updates that I don't have yet. So yeah, Merkleization is a really great data format. So it should allow for more performant websites, not less. And we're still in this weird phase where we're like, cool, we used Merkleized data to gossip, but we don't have it all the way up to the UI layer yet. So we're still like asking about it through a really cruddy API. And then in addition to that is just sharding. So right now, transaction fees are increasingly inhibitively expensive, and people need to be able to establish lower cost consensuses among groups that they have more trust with, or maybe don't need global blockchain security on. And I think that there's enough proof that I think sharding is going to happen, and there's just a big question over like what's that UX going to be like. I mean, we barely know how to query a Merkleized contract database, but how to query a Merkleized contract database that lives on several different blockchains with different consensus protocols, and how to maybe do a selector from one to another or something. Like these are not just user experience problems. It's really not just MetaMask problems. Like we're injecting the API, but we're like keeping up with developers, but like coming up with these standards, what they should look like, proposing them, writing layers that implement them, I think is like a huge area to like offer new value to this ecosystem. Yeah.
Does MetaMask have like a revenue model? Is it eventually gonna have like a subscription, or will there be ads on this?
I don't think we're ever going to have ads. Right now we're open source. It's like MIT open source, so you can just fork it. I think we've got a trademark, so you got to rebrand it if you want to fork it. Our revenue model right now is we're a spoke of consensus, and they have a ton of projects that need an identity system and need people to have blockchain clients in order for any of those things to work. So we're kind of like an infrastructure thing. We do have a few ways where, like I mentioned, the possibility of white labeling, like once we have an extensionless version. And when you buy Ether within MetaMask today, it'll take you to like a little Coinbase widget, and we get like 1/3% or something on that. I think we've made enough for a round of beers at this point. Haven't had that beer yet, but yeah. So I think right now we're kind of being sponsored because we're enabling greater kind of ecosystem experimentation. So yeah, we're very privileged to be in that position, but we do have some ideas of how we might, if we needed to milk it for revenue, offer services and stuff. And yeah, if we were going to do tokens, my latest idea is we sell support tokens, because we are stretched so thin. Like I showed you that exponential growth chart, like those are all just people that don't know what a blockchain is or what gas is, and it's like really, really stretching us thin. So just like any way of like allocating our time better right now would be a smart move for us. Yeah. Cool. Yeah, that was fun. Thanks for all the questions.
All right, can we give another round of applause to Dan? That was amazing.
Yeah.